You will need to save this video if you are an A-level maths student, because in recent past exams, I am seeing more sequences of series questions with trig functions involved. So in this video, I'm going to go through an example to show you how a potential question could work. Let's say that this sequence here is geometric. But not only geometric, let's assume that this sequence is convergent. So as the sequence progresses, the sequence is converging to a value. So we've got a geometric sequence, which of course means that we're multiplying by a common ratio of r every time, right? So as we got up the sequence, we times the previous number by this common ratio r. And because it is a convergent sequence, we need this r value to be between 1 and -1. Okay, so that ratio must be trapped between -1 and 1. So the magnitude or the modulus of r must be less than 1 in order for it to be convergent. Now, hopefully you can see that 4 sine x times r is equal to cos x. And hopefully you can also see that cos x times by r is equal to cos cubed. So we can kind of form two simultaneous equations here, right? So we got, as I said before, this equation, and we've also got this one here. So now what we can do is divide by some variables on both sides. So on the first equation, divide by 4 sine x, we get r equals cos x over 4 sine x. Divide by cos x on the right equation, so we get r is equal to cos squared when we simplify the coses. So hopefully now we can see that we can put those two equations equal to each other, and we get cos x over 4 sine x equals cos squared when we do that. Now just a little note, r cannot be 0, as we said before in the question, right? I stated clearly that r is not allowed to be 0. So that does mean that cos x can't be 0, okay? Because remember that ratio, that r value is cos x over 4 sine x, so obviously cos can't be 0. Not too important, but just something I thought I would emphasize. So what I've done here, there's a few ways you can go about this. I've just flipped the fractions upside down. Okay, you can perfectly do that, that's fine. So what we get is we get 4 tan x, because sine over cos is tan, is equal to sec squared. So remember, 1 over cos is sec, so 1 over cos squared is sec squared. So then we've got 4 tan x equals 1 plus tan squared. Using our trig identity, 1 plus tan squared equals sec squared. So now we've kind of formed a kind of quadratic here, right? So 0 is equal to tan squared minus 4 tan x plus 1. If we let y equal tan x, then we get this quadratic here. So now we can go ahead and use the quadratic formula. We want the exact value, okay? So you can't just get a decimal number, right? We want an exact surd value. Exact values mean surds, don't forget that, right? So use your quadratic formula, simplify the numbers that we get here. We'll get 4 plus or minus root 12 all over 2. We can then split the fraction into 2. So we're going to end up with 2 and then plus root 12 over 2. Root 12 simplifies to 2 root 3. The 2's there cancel out in the fraction. We get 2 plus or minus root 3. So tan x must be equal to 2 plus or minus root 3. So you could do tan inverse and get the x values. What I've actually done here is something a little bit different. Notice how the r value, the ratio, is cos x over 4 sine x. And notice how that's a quarter times by cos x over sine x, which is a quarter times by 1 over tan x, right? Because that is 1 over, because cos x over sine x is 1 over tan x. So we've got a quarter times by 1 over our two tan values. We know that tan is 2 plus or minus root 3. We worked that out. So plug in those tan values. Now we could just rationalize the denominator just to make these numbers look a bit more simplified. So once you do your rationalizing and simplification, hopefully you'll see that you get this. So a quarter times by 2 minus root 3 over 1. Or alternatively, a quarter times by 2 plus root 3 over 1. We can now simplify everything. We get half, take away root 3 over 4, or we get half plus root 3 over 4 as our second potential ratio. Now, as we said at the start of the question, right, we need the ratio, the r value, to be trapped between -1 and 1. We need to check if they are. Sometimes with these questions, you'll get an r value which is not between -1 and 1. So you've got to check. You've got to go back and check, are these two r values trapped between -1 and 1? And hopefully, once you do the calculation, you'll see they are. So the first one is about 0.067. Next one's about 0.9. So they are trapped between -1 and 1. So we've got two potential ratios. Now, what you can do for yourself if you want a bit of homework, try and find the sum to infinity in both of these cases. We got the two r values. Both of those r values will have a different first term. So remember, a is your first term. I want you to see if you can do this yourself, right? So see if you can get the sum to infinity in both cases. We've got two cases. Can you work out the sum to infinity in both cases? I do have a free revision guide. The link is in my bio on sequences series. Do save that for your revision. I do think it's a useful guide. Again, it's in the link in my bio. Let me know if you've got any questions.